One thing we need to understand. Okay, so yeah, so that is the first point about descriptive statistics. You do some data analysis, and based on that, you find out some description about this. Like, you did some income analysis and found out this is the income of a pediatrician, this is the income of dentist, this is the income of elementary school teacher, this is the income of police officers. This is what is descriptive statistics. Okay, this is, this is part of it. So you already do that when you get a data. This is the first thing you should be doing. Descriptive statistics. Make sense? Okay. So data like this, and you want to bring some analysis out of it. Okay, you do that with descriptive statistics. Okay, you do that with descriptive. Descriptive statistics means whenever you, I show you this function describe, right?
Yes.
Describe. Data frame dot describe, it will show mean, max,
Yes.
right?
Yes.
And it is also part of descriptive statistics. Okay. Okay, so descriptive statistics deal with basically describing the data. Okay, just descriptive. It does not even generalization beyond the data at hand. Okay, whatever data is there, from there you are doing some description. Understanding the data set doesn't go beyond it. Generalizing from our data to another set of cases is a business of inferential statistics. Okay, inferential statistics means the inference that you're trying to make. Okay, the branch of statistics concerned with drawing conclusion about population from sample. Now this is the important term. Okay, and this is what you should be knowing. Okay, there are two terms here. The entire, you'll mostly never have the entire population of data. Entire population of data means entire collection of data. If I tell you, okay, I'll give you employee data, and you have to figure out their lifestyle. Okay, I'll give you employee data and have to figure out their lifestyle. It will never be possible for me to give the employee data of the entire world, right? So whatever data I'll be giving you, it will be a sample subset. Okay, so the entire data is known as population. Okay, subset of data is known as subset of data is known as sample. Okay, if the sample is a good representative of the entire data set, that is known as representative sample. Okay, so you cannot do all the analysis on the entire world, on the entire population of data. You will do only on the sample of the data, whatever is available to you. This is known as and based on that you will conclude about the entire population, isn't it? You will do work on the smaller subset, and assuming that the smaller subset is a representative of the entire data set, okay, you will conclude something about the entire population. This is part of your inferential statistics. You are inferring something about the entire population from the sample data. understood the meaning and difference of inferential statistics?
To draw conclusion out of.
Right. Okay, for example, in statistics, we rely on sample. Okay, and that is the smaller subset of the larger data set to draw inference about the larger data set. Okay, so people use the term population. What's the population scope? What is the sample subset? How good is the representation? You know? The larger set is known as population, and from which sample is drawn. Right? It is not practical to ask every single American how he feels about the fairness of voting procedure. Instead of that's what you do, right? After the election, you pick out some sample of folks and understand whom they have voted, and assuming that they have a representative sample, you can conclude that this party is winning.
Exit polls.
Exit polls. That's what it means, right? Okay. The mathematics procedure whereby we convert information about a sample into intelligent guesses about the population fall under inferential statistics, right? That's the thing you. Okay, but there are a few things to take care of. You know, if your sample that you're picking up is not the best represented, you might ending up giving wrong conclusion. Say, for example, election is happening, you ask only BJP supporters have you voted, then your exit polls are very much polarized, right? And that is what happens many times. So, okay, so that is where your ability to pick up random information becomes very important, right? That is why you use a lot of techniques so that whatever sample subset you are getting, right, that is a good representation of the entire data set. Okay, so there are techniques by which you will be doing that.
But this is the correct sample data or not? Like, how will you identify it? This is the correct sample data or not?
So I'll discuss about that technique. There is a technique for doing this. In a nutshell, since you asked here, right, let me give a very layman explanation to that. You have a huge data. You like employee population, huge. You pick up 2 samples or n samples from the data. Understood, right? From one sample you are concluding something. From another sample you are concluding something. From another sample you are concluding something. Now, when you start concluding similar conclusion out of different samples, what you can conclude that this is this is the good samples. Understood, right? In a nutshell, this is known as central limit theorem.
Central
limit theorem. Okay, so that's what it actually is. All these things we already do. We just have to wrap around the right terms here. That's all. Okay, so now let's hear some important more terms, variables. Okay, so there are some more terminologies here. Okay, now that you have seen a lot of data, not a lot of data, some data you have seen, technical data you have seen sales data, right? Varieties of data you have seen. So you have seen some CSV files which who have quite a few columns, isn't it? Like if you imagine house price data, we have seen house price data, right? So your last column is a price, isn't it? And here there are square footage and different columns here. Okay, so if you say this price is dependent on all the other things, these all column names are known as variables. Okay, and the columns which are the column which is dependent on other columns is known as dependent variable. Like this price column is known as dependent variable. Okay, another variables which are not dependent on anything else is known as independent variable.
Like index.
No, index is not a variable actually. It is just row number of the data. Okay, but other thing like square footage, number of bedrooms, number of bathrooms, these are known as independent variables.
Nothing but the features.
Features, yeah, right.
Since your price is dependent on your square foot area,
right?
Because your base price multiplied by square foot will give you the actual price. So that becomes your dependent variable.
Dependent variable.
So your price becomes dependent variable.
Your price becomes your dependent variable, right? Got it, right? Okay, so you use the term that way. So in supervised learning, we'll see later on that we're trying to predict dependent variable. Okay, now there are more types of variable. One is qualitative variable and is quantitative variable. Okay, qualitative is variable means the values are represented in qualitative attribute like hair color, eye color, religion, favorite movie, gender, etc.
This is quantitative.
This is qualitative.
Qualitative.
Yeah?
Mostly this will be like categorical data.
Right, this will be categorical data. Understood, right? Like color, male, female. This is option. Okay, location. Right, this all belongs to qualitative. Okay, so quantitative variables also can be measured in two types. This is qualitative, male, female, and all that. So quantitative measured in two types. One is discrete, one is continuous. Right? Discrete means the number is fixed, number of children, like 1, 2, 3, 5, 7, sorry. Number of children, right? Some limited numbers will be there and all that. Then you have continuous. Continuous things can be rainfall, 1.2, 7.5, 3.7, right? So, okay, so that is discrete and this is continuous. Okay, now a few more important things. Okay, which is not mentioned here. Categorical values can be nominal or ordinal. Categorical values can be nominal or ordinal. What is nominal? Nominal means there is no relationship between the data, like male, female. Right? That means ordinal means low, medium, high, where the one data is larger, supposed to be larger than another, like location or gender. These things there is no relation. You cannot say one thing is greater than another or something, right? So that becomes nominal data. Okay, and ordinal is where there is an order in the data, but this is both for categorical data. Understood, right? So you have low, medium, high. That is part of ordinal data. Low, medium, high.
So that one not encoded would be for this nominal data.
Right. Okay. So now understanding where does your data fit in. So for that, percentiles we have to understand. Okay, what do you understand by percentile?
That means that many percentage of people are below us.
Exactly. So this is basically location of data. Okay, that is what percentile is. That's what I'm saying. Lot of stuffs, but putting a frame. So what is percentile? Like, if you say 90, I got 90 percentile, that means 90% of people are below your, numbers, right? So that is what percentile does. Percentile finds where your data is located.
So is that true that, let's say, I have that somebody who has got the highest mark, somebody who has got let's say 95%, so that becomes 100?
So in colleges these days,
Yeah.
they have this CGPA system.
Yes.
That's what it means actually.
So
Okay.
for example, you have scored 96%, 100, you like that becomes your benchmark 100%. So below that,
right. Right.
Like
that's what it was. So there's a funny story around it, and this is a good thing, why? So what happens after? See, I mean, now everybody is aware of, like 10 years back, when 10, 12 years back, this was a new thing. I mean,
Yes.
prior to our batch, it was always percentage, and this was percentile. The benefit of this is the percentile will always, I mean, you will always be with respect to the highest mark, you can always easily be in the 70-80% category.
Exactly.
Right? And rather than explaining anybody what is your percentage, that's what we'll do. So multiply 10 there. Yeah. We know that is not what it means, right? So that is what happens when you don't know statistics. So you could make use of the situations, but now it's not the case anymore. Now schools also have percentile, is it?
I think from your batch it would have
started. Yeah, that was the year 2000.
From our batch it was percentage. Next batch itself, that trend has started.
It was all percentile, and we just wanted our high topper to score less. That's all. Okay, so that's what your percentile was doing. It was finding the location of the data. Location of data.
Is there a standard formula to
calculate? No, actually, it's here. It's here. Okay. So, for example, say, for example, this is a score and this is a rank. So you want to find who is. So suppose you want to find what is the 25 percentile of the data. Okay, 25 percentile of the data. This is how you do actually. So here you calculate IR, and for 25 percentile you are doing this 25 into 20 plus 1. This is the highest value, and this is the lowest value. 1 is the lowest value, right? So that's what the formula is. Okay, so here you can see the first step is to compute the rank of the 25th percentile, right? I mean, this is the data, this is the data, this is the data, and this is the rank. So what you're doing here, okay, so you want to calculate 25th percentile. So you do 25 into 100 into n is your total number of ranks that you have, 8 plus 1, so 2.25. So you want to know what is the 25 percentile? It will be probably somewhere here. Understood, right?
Yeah.
Okay, so if you have to calculate, what is the 100 percentile? What will you do? 100 into 100. 100 divided by 100 is 1, right? Into n is your 8 plus 1, right? And there is 8 plus 1, so 9. So yeah, that's what it becomes, I guess. Yeah, I remember it was one thing more than that actually. Okay, so that's what. So if you say 50, so it becomes 1 by 2 into 9, that is 4.5. Somewhere around here would be the 50 percentile y. Okay, so you have direct APIs to calculate that as well, and say here this is the data you want to find, say 25 percentile over here. So that's what you're doing. 25 into 100 plus 20 into 1, that is 5.25. So here it will fall somewhere here. $85 percentile. So that's how you are calculating the percentile.
The IR and FR that you're talking about?
FR is the IR is integer portion. Okay, FR is your fractional portion of R. Okay, so integer portion is like this is nothing but you are getting this result here. So what will be the result? The IR is this part, right? 25 is 0.25 is your fractional portion of R. Okay, that's what nothing much. I mean, generally this doesn't get used as well. So I think now measurement demonstration, there's nothing much here. Yeah. So now we'll go to distribution. Okay, distribution is very important part of information. Okay, so what is distribution of data? How is data distributed? Like for example, if you have a table, it has all the employees of a company's information, right? And so all the employees are there. One of the column is color of eye. One of the column is color of eye. Okay, so color of eye can be brown, red. Oh, sorry, red. Why is it? Some other stuff. Okay, some other cloth color or something like that. Yeah. So you have some color of eye information. So you first wanted to understand what is the distribution of this, right? So you will see here that frequency distribution means telling it how much is the frequency of occurrence of each element, right? You can see here brown is this, red is this, so this columns are this way, right? So it basically tells you the distribution. So if you, this is the frequency table first of all. Okay, if you plot it, this is what we are using bar graph for plotting it. This is the categorical value. This is the occurrence out here. So if you have to project, if you have to show distribution like this, you can use bar graph. Okay, just keep this in mind. Okay, this is categorical value and this is the occurrence of it. Okay, now of course you can convert that into proportion, right? Occurrence was there. You basically would, for each occurrence you will divide it by total number of occurrences, right? So that will create a proportion or frequency distribution. Sorry, this is probability distribution, right? Probability distribution, how much probability, like sum of all these things will be 1, right? This is known as probability distribution. Okay, and the so all the what is this probability distribution? Okay, so what does it mean if you're picking up something? Picking up a random element from the data? What is the probability of the data belonging to part 2 any of these classes? That is why it is known as probability distribution.
So this will always become 1.
Sum of all will be 1. Got it, right? So like you can see 3 plus 0.2 is 0.7 plus 0.2.
Category, like category.
Right.
Some of the categories will be always one.
Right.
Correct. 1, 20, 20, 30, 50, 70, and then 30, 100. Yes.
Okay, so this is categorical value and the frequency of their occurrence. Okay, this is known as probability distribution function. Okay, let's see more. So if you have continuous variables, right? Continuous variables means, so you can see, this is a like say for example, you are this is, suppose you have a data set of rainfall. Okay, rainfall data set. Okay, you can check out some repositories. UCI has a data set, rainfall data set, where it will have each day and rainfall record. What is the rainfall each day? So if you do group by of, I mean, if you're doing grouping based on certain values, you will are seeing that, if rainfall 2.7 is there in 5 days, 2.8 is there in 7 days, 3.7 is there in 11 days. After doing some basic operation, this is what you figure out, right? So this is continuous variables. So you cannot keep plotting. I mean, how many such options are available? Huge. Yes, right? You cannot keep plotting one bar for each of them, right? So what is the next thing that you'll do? You will bucketize.
1 to 5.
Absolutely. 1 to 2, 1 bucket, 2 to 3, 1 bucket, 3 to 4, 3 to 4, 1 bucket, 4 to 5, 1 bucket, and so on. Yes. And for each of them, we'll combine whatever data is coming here. So this will be one frequency, another frequency.
I would also like to give an example with this. So what happens is that your retail data, retail your store data. Right. So what happens is that your price. So there will be MRP. So MRP is also a measure value. It's a factual data. But what happens if somebody wants to see, like a manager want to see in 0 to 99 or 0 to 499 how much sold. So what you will do, you will be grouping it. Like your measure will become a dimension attribute.
Right.
So that you will be, it will play as a dimension, and you have to plot it against.
Right. Absolutely.
So similar.
Absolutely. This is known as the grouped frequency distribution. At the same time, like you can see here, like he was speaking about 0 to 99, and what's the frequency? Yes, this is grouped frequency distribution. There is probability distribution, this is frequency distribution.
So काफी सारे report बनाए हैं उनके मतलब, and then real time lobby tool में I've worked on these kind of scenarios a lot. But never knew that this is called as group frequency distribution.
That's what nothing. Okay, so this is group frequency distribution is also known as histogram. Right, and this is what you will plot. There is a function directly to plot histograms actually.
So, how will you be grouping this data? There are functions to group.
Group by
Group by
functions.
That-
Okay, so like for example, if I'll show some examples. Okay, just one after this notes, I'll show some. I'll get back to pandas and I'll show some cases. Now, this is what we have seen so far. Let's build further now. So there is some term that will hear entire your life is known as normal distribution, or you've already been hearing that. Normal distribution is what your manager tells you when during the appraisal bell curve. You're in the middle of the bell. Okay, so mid bell curve means what? A lot of people fall under this bracket. Okay, so either very less people when the appraisal statistics has happened, analysis is happening. Very few people fall under this category, or very few performers. This is underperformers, this is overperformers, and the majority falls here. Right. So most of the natural occurring items are of this category.
And also, is it true that let's say I am making someone a high performer, I have to put somebody in the low? Is it some rule or something?
Yeah.
Let's say I'm not putting somebody in high. I can.
No, not rule in the same management rule. I don't know.
Okay. No. I'm just from statistics perspective.
No. It will automatically happen. Like if you are trying to find out your happiness factor, happiness question. Let's take. So there will be some days which is relatively dull, as you can see here. Some days where we are extra. This is the happiness question, and most of the days we fall under this bracket. So most of the naturally occurring things will have normal distribution. This is known as normal distribution. There are certain properties around it. Okay, so this is the normal distribution. This is a normal distribution. This is a normal distribution. This is a normal distribution. Right, and there are certain properties around it. Okay, sometimes this is positively skewed. Positively skewed normal distribution means positively skewed normal distribution. The graph is something like this, right? Negatively skewed normal distribution, so graph is something like this. Higher values are very much, lower values are very much. Understood, right? So this is like income. Income data is always something like this.
What is lower distribution?
Not income data, but yeah. So
but it is becoming high.
This is positive. It will be high initially. After that, it will be all the other values will be less. This is income data. All lot of data will be for income data is something like this actually.
But the result is same. Right?
I've seen such data. This is where this is salary. This is salary. Sorry, it was reverse. This is salary, and this is count. Got it, right? This is salary. This is count. Salary is increasing this way. So there are very less people who has very high salary.
Yes.
And a lot of people with low salaries. Understood, right?
Positive distribution, other one is
negative. Again, Okay. So this was as of now we have seen this normal distribution which is one peak, isn't it? Now we have more distribution which is two peak. Can you see this? This is known as binomial distribution. So distribution with two peaks. Distribution with two peaks. Is binomial distribution. Understood, right? We data like this.
But there could be n peaks also, or no?
That is that there is another category. Two peaks is for binomial distribution. If you want to see it. And there is a formula for this curve also. Understood, right? The normal distribution curve is there, or binomial distribution curve. There is a formula. So this is the you understand why there will be formula. Everything has a formula, right? Every line, everything. So here also you're finally forming a line, isn't it? Here also you're finally forming a line. Okay. Here also you're forming it. Here also you're forming a line. Okay. Say. Okay. So this is the curve. Okay. Here also you are forming a line. Say for example, you're forming a line like this. This also has a formula. You're forming a line like this. Every line will have a formula. Okay. So that's what it is. So binomial. So all this normal distribution, binomial distribution, everything has a formula associated. Okay.
Looking under that data, will come to know which is the distribution which you go.
Okay, as long as the data suffices, that formula for normal equation is a normally distributed data. A lot of machine learning algorithm works well if the data is normally distributed. Okay, so there is a term here, distribution also differ each other from how large or fat their tail is. What is tails of distribution? Okay, so this is, yeah, so if the tail is like this versus the tail is like this. Tail is thicker here, right? Tail is thinner here. So this is also two types of different types of distribution. So okay, if there is a curve with fatter tail, there is a curve with less, thinner tail. This is the upper distribution is relatively more coarse in its tail. Okay, it is called leptokurtic. Okay, relatively fewer score in the tails. That is called platypurtic. We just keep these terms in mind. The tail also matters, and there is a term for that as well. Okay, if anybody tells you what is the difference between a graph which has a thinner tail like this and a graph which is thicker tail like this, what is the difference between the data?
Like it is concentrated in one.
This one,
There are large data out there.
thin tail. Thin tail means the distribution is large. The min-max value will be quite large ranging, right? The data, so if you plot this above data in a graph, so it will be coming like this, large area it will be. Okay. Whereas because the min-max value is very much distance, right? Whereas this guy, we can be concentrated in a smaller area. Understood? So density will be more. Okay, so that is where the density theory, all those things comes into picture.
I think इतना concepts है मतलब फिर there are a lot of concepts.
बहुत आसान नहीं है.
आसान है, but okay, maybe like I said again earlier, I'm used to
नहीं, and that is the only way.
Yeah.
Languages are too much.
But meaning is very simple.
Simple, yes.
Right. So that's why I have given the simplest book. I'm not telling you to read the heavyweight books because it's very easy to get carried away with those. A lot of people get in depression reading those because oh shit, there is too much to learn, and indeed there is too much to learn. But if you take that step-by-step process, right, a lot of people actually gain a lot of mileage here.
They will take the base of the example and
And fortunately, right, at least for working people, you already see a lot of stats. You have news to feed you, you have magazines to feed you, you have office data to feed you, you already have seen. So all I basically have to do is, just connect with the term. That's all. I'm hardly explaining a lot of things, right? I'm hardly getting into those details, but you guys are able to follow. I think everybody is comfortable with the summation notation and all that, right? Okay, let's see. Okay. Now let's go and do some Panda stuff.
related to the statistics part of it, the pandas.
Because we can use pandas to do almost all the statistics. Training data. Okay, so you have this. You want to find now a gender-wise distribution, right? So what you can do here, you have an option of group by. Okay, group by sex. Okay, and which column you want to group by? Size. Right, you can see here what is it doing? It is grouping by sex, and it is giving you count based on that. Next thing is if I want to group by age and see what is the age distribution. Understood, right?
Yes.
For the data. So of course, the first thing that we have to do is get rid of all the non-age, which is all the rows which do not have age, basically. Okay, right. Unique data dot age dot not null. Titanic data. Titanic data age. Okay, you have all the columns. Now what you want to do, you want to basically do group by, I mean, the age factor, right? Like 0 to 10, 10 to 20, right? That is what you want to do. So, yeah. And then you want to find the frequency out of it. So you basically would do this.
Only button we try to do here. I'm dividing my time.
So what I'm trying to do here is I'm basically trying to find what age distribution. I want to do that plotting. Okay, of 0 to 10, this is the number of population. So
Okay.
first I have to find which age group does it belong, right?
Okay. Yeah.
Okay, so once you have okay, so you have these are the age brackets, right? So you basically could do this, tightening data age. EKT. Okay, so we have this age bracket here. Now we want to do group by. Age. Which will 2.2, it will convert into 2 floor. Okay, ceiling is 2.2, it will convert into 3.
Higher
Right. So this is the distribution here. So a lot of people are between 20 and 30 age group. Yes, something? Shell. Ceiling, CEIL. Ceiling is higher value. 2.2 will give you 3.
Floor, ceiling, round, all will give different values. They're not same.
Round off will give it into 2.
Yes.
2.7 into 2, but I basically want the bracket bucket. Yes. So that is why. So you can see here, this is the distribution here, isn't it? 0 to 10, there is 62 people. Majority of the people are in the 20 to 30 bracket. That was sailing in the ship.
Just roll up.
Age divided by 10, why you doing?
Huh?
Age divided by 10.
10 because you want to find the right bucket. Which bucket you want to get into, right? Yeah, that's what she was asking. Yeah, because if you don't do that, you're not actually doing group by frequency. I mean, grouping frequency distribution, right? That's why we need to divide it by 10 because you want each bucket to be of size 10.
89 रुपीस में आता है.
Which is why the bucket.
Yes.
Okay. Now the next thing is we'll try to understand what type of plotting is good for what type of graphs. Okay, so that when we'll learn shortly. After this, we'll learn doing matplotlib, and then we'll try to plot each of these type of graphs.
एक इंटरव्यू में मुझे पूछा था why we use pie chart. What is the significance of use pie chart?
Pie chart. And we will ask that because knowing things are different than only when you do that you realize why do you need it. So okay, so pie chart you see here. If I understand, you can. What is it? This is the data here. Huh? This is the data. This is different ownership, and this is the frequency. Right? Total is 500. 355 use Macintosh, 60 use Windows, none use Linux or any other platform. And this is the distribution here. Right? Percentage. And if you're plotting it over here. So what type of data is good for pie chart?
When you want to derive values within same set, for example.
We cannot have continuous data.
We cannot have the distribution.
Yes.
If you remember, we saw probability distribution, right? You can plot that as pie chart because you have probability distribution here. Once you have probability distribution, we can plot that as a pie chart because sum of all these things will be. So it is used for plotting categorical data distribution. Plotting categorical data distribution. Understood, right? Categorical data distribution. Okay, so bar chart also gives you the same sort of distribution, like number of buyers you get. It's basically showing you frequency distribution here. Probability distribution pie chart, frequency distribution this guy. Okay, so we have next is comparison, right? If you have to do some sort of comparison, you can use horizontal bars. This is horizontal bar H, horizontal bars. Here you can show the comparison between Wednesday sales and Sunday sales. right? So this is how you can plot comparison comparison information, comparison of frequency, comparison of not frequency, basically, yeah, you can say frequency. Yeah. Frequency comparison can be done by this.
You have APIs for this.
Huh?
You have APIs for this too.
Yeah, we can use matplotlib also. What you can do is you can use
What is this particular like graph called?
This is also
bar H, horizontal bar. The early
even you can do in vertical as well. Vertical also can be done. Only thing we need to consider here is like sometimes what happens is that your width, it has to be fit. You have here bigger length and in your vertical. Horizontal might be. So what happens is that usually one of the best practice what we follow is we should not allow users to do a horizontal scrolling. So they should not go like this. They can go like this, but they should not go like this. That's why this is,
absolutely. I'm with this program as well, but absolutely. So if you have a lot of information, you have less information, that previous thing is fine. If you have a lot of information, if you plot horizontally, either it, if you're not giving the sufficient space, it will be jumbled up. Readability will be less, and this is what makes more sense. And do it in the increasing order, yes, or decreasing order. Plotting, so that and okay, so this is plotting more information. So this is the area plot again.
line graph.
And there's the area inside it. Okay, so what is we can see the trend of this. The area plot is different. Sorry, trend of this and trend of the blue curve here. Right. So refer to this. This is a very important question that I will be asked. What plotting should I use for this? Fall back to these strategies. Go. I mean, it's okay initially to go back and cross check here. What is this guys recommending? Right.
Just to add one more thing in line is line is always used when you have time associated. It will always easy to populate line.
Time is one of the parameter. It can be anything to do like here you are seeing here. See, it's not really the time always. So time is definitely one of the parameter that people use, like stock data. Okay, but apart from that, you can even the same information that we saw earlier, we can use that as categorical data. But if it is time related data, it is always for sure a line graph. Okay. Time because of course you can plot histogram and all that, but you want to give that impression of what is happening with respect to time.
And there's also one more bar and line. Bar and line.
Yeah, we'll come to that. It's a long list.
Yeah.
Okay. Here you can see. So this is just first thing that we saw. This is for qualitative. Understood, right? So this is the good part here is, if you have qualitative data, you can use all these techniques, whatever we have shown now. If you have quantitative techniques, okay, so of course the above things can be used. You can use okay, all the above techniques that you've seen, right? That can be used for quantitative techniques as well. All the things. Okay, stem and leaf displays. This is the old, very old technique, still useful. So you can see here. So some numbers are there. Okay, this is very similar to what I did just now actually. So here 3, how many times 3 is appearing? 3, 3, 7, 3, 3, 2. right? 2, 3, 3, 7. Okay, this is known as stem, this is known as leaf. Okay, we can of course have multiple levels of it. Okay, but one is known as stem, another is known as leaf. Right, because I mean the terminology again here, it's nothing. It's calculated, tens place will be the stem and the units place will be the leaf.
What if 3-digit numbers?
Hmm?
What if there are 3 digits?
The system might get thicker.
It's just a representation of data or like
It's a representation of data which explains you the distribution. See here, you're getting some distribution sense, right? The distribution is like this, isn't it? This distribution is like this. It is fat towards here, it is fat towards here. Got it, right? This is known as leaf and stem distribution.
First time.
No, you would have heard of
Maybe.
in school.
That's yeah.
It was there. I still have.
Okay.
It was there. It was there in regular works. So then histograms. We have seen that.
Scenario will use this.
Huh? No, it's very basic one, right? But you should know. Okay, that there is something like this. Like actually, whatever we did now, some format of that only. Right? If you can just calculate tens digit, I divided by 10 and all. That's basically I wanted to get tens digit and all that. Right? Do that to the stemming only, stem and leaf graph distribution. So again, now you will see histograms. Histogram is for what? It's frequency distribution, right? You can see here, this is the value and this is the bucket, 59.5 to 69.5. This is the bucket and this is the frequency that is coming here, right? So this is histogram. We can use it for discrete data also. Absolutely, it will be there.
Only difference I could notice is your bar charts are like
see, histogram is for continuous data.
continuous, yes. So they are like separated. Here it is a continuous.
Alright, histograms are more for continuous nature of this between the ranges is happening. This is happening. Okay, then comes your frequency polygons. Okay, so as you can see, it's nothing but from each. This is the score, right? But you can do that if the range is not very high. This is the score, this is the frequency, and you are connecting to that and joining this graph here, frequency polygon. Okay, then there is a cumulative frequency polygon. This way back to we used to plot that in pink color graphs, right?
Yes.
I don't know how kids do these days, but yeah. So here you can see this is for this, and there is known as cumulative frequency polygon. Okay, so what does it mean? Above, below this, how much people are getting? So it just gets added up here. This is the trend. Cumulative frequency.
Graph notebooks only for statistics.
Huh?
Notebooks only, graph for the notebooks specific.
Right.
Green or pink.
Yes.
Green or pink.
That time it was in our time it was not. Yeah, it was there, I guess. Yeah, it was there. It was there. It was there. 10 marks, 15 marks.
बोलते थे लेके आओ तुम्हारा पेपर लेके आना ग्राफ पेपर
हाँ ग्राफ पेपर लेके आए
जो लेना भूल गया मतलब तो भूल गया कुछ
there are friends who carry extra okay so this is your cumulative frequency, right? What is happening over here, this is like whatever has happened till here plus the guys before it, that is cumulative frequency. Okay, that is what makes the graph like this.
we call it as running sum also.
Yeah, can't call it
Running sum also.
Okay, this is very important, box plot. This actually gives you not box plot, box plot. Where is that line? Box plot line. So it actually gives you how this is the thing. So for a data, right? It first like so this is female female data. In female data, you can see the time information is the minimum time is this, maximum time is this. Say you have calculator. I think it's just the information now. Suppose you are calculating stats. How every student and the time he took. Later on, you want to do some generalization based on the gender. So what you did it for female, this is the data. This is the minimum time she took and maximum time she took. This is the minimum time a male took. This is the maximum time a male took. Right, and this is the mean time. This is so what this box plot means. You can directly do that plotting. This is very useful in understanding the distribution. It means this is the max data. This is the min data. This is the 25% of data. This is the 75% of data. This is the mean.
Just come down. Just the next class. Yeah, here. So, what is that circle here? Near to 30.
You must be explaining something with that. See what this means.
Options.
But the distribution is same. So, per hinge, don't generally use it actually. Okay, then you have dot plots. Not this. Yeah, this is what. Not this. This is something known as scatter plot. Yeah, this can be something. Scatter plot. Okay, it will do the plotting like you have four information. Like this thing I'll discuss when I'm doing the plotting, learning the plotting part. You have four information: x, y. Like x, y is a latitude, longitude, size of population, and density of population. If you have this four information to plot, you can plot that in scatter plot. Okay, x, y axis, size of information will show the bubble size, and density of population will be shown by the color of the bubble. We'll do that, but this is like four otherwise it's 2D information, right? That you can plot, right? You cannot plot more than 2D. That is four information at a time.
So all this we have to write some of the other line of code to
show that. So I'll so do a thing. We have in the community page you'll see the matplot link. Okay, this is one thing that you can try a little bit over the week. Okay, as you can see, there are data visualization in matplot link. Okay, so you can try this all this. This is whatever I have explained. This is the plotting part of it. But we'll do that. Okay, people sometimes find it a little difficult to understand, but we'll do that. The other option is Matplotlib is one library that you can use. Another library that you can use is Plotly. You guys use Plotly in Office or Tableau?
हम लोग Oracle I just opened.
You're using Tableau.
Yeah, Plotly is using not application.
Oh,
But that product what we're using is using Plotly.
okay. That's good.
हम लोग का ये use this one. So
This is what?
this is Oracle data visualization. This one.
Acha.
This means someone will have. इसमें what you can do is you can apply your, or you can call your model. Once the data is here, you can plot using this tool. So you don't have to write explicitly anything.
This other library is Plotly. Yeah, the functionality is similar to ggplot, absolutely. Actually, ggplot is better than Matplotlib, but Plotly is good, but it is not free. But if for yourself, you can use it for free.
It's Plotly.
Matplotlib, this is Plotly, this is another library.
Anyway,
Matplotlib is foundational actually. Password.
Or we can directly upload data here and we can see the charts.
Plotting.
Plotly.
You can do that. Also, you can plot it in your web. So actually, I'll try logging. Yeah, why is it not taking me password? Okay, so like Plotly on Jupyter, so that your graph starts showing there. Okay, so
This is for the Jupyter notebook, I think.
yeah. Oh, Jupyter Notebook tutorial they have downloaded. Yeah. Something is wrong here. Okay, so anyway, these are the two things. We'll start with mostly Matplotlib, but these days I'm introducing Plotly also because a lot of companies have started using that, though it is not free. The visualization.
On Plotly only, my product.
Oh, is it? Actually, that's why a lot of companies, even though it's paid, but people are not ready to compromise on the visualizations. Seaborn is another such library, which is free, but a lot of companies use Plotly because of the.
but for learning purpose, we can download. And,
Learning purpose, you just have to pay me. Just kidding. Okay. Okay, so go through this stuff. Okay, read a little bit about those statistics. There are a lot of good books, but first focus on online stat books, easy entry. Okay, after that you can read these bigger books. Okay, Nilanjan, Sonal, I'll end the meeting.